Hello ladies and gentlemen, welcome to my YouTube channel. I'm aware that June exams are now around the corner, so today I'm going to provide final exam tips on industrial processes that is most likely to be examined in June 2024 under chemistry section. At O-level combined science, under industrial processes, we are expected to know about production of peanut butter, production of soap, fractional distillation of liquid, or we can say liquefaction of air, electrolysis, Haber process, electroplating, and conduct process. So I want to look at the trend from November 2020 to November 2023 and be able to highly predict which industrial process is most likely to be examined in June 2024. So first we are going to look at the industrial process that was in November 2020. So in November 2020, the industrial process that was examined was on electrolysis and electroplating. So next we are going to look at the industrial process that was in November 2021. In November 2021, the industrial process that was examined, it was on soap production, where candidates were supposed to name the process of making soap, describe how soap is produced from vegetable oil, and state the second product of the process named in part 1. So in 2021, the industrial process was on saponification. I want to look at the industrial process that was in November 2022. So the industrial process that was in November 2022, it was on number 12, where candidates were required to answer the question on production of peanut butter. Let us now move on to June 2023. So this was June 2023, Combined Science Paper 2. The question on industrial process was on number 11. It was a question on liquefaction of air. So candidates were required to describe how atmospheric air is liquefied, state any component of air which is removed during the process, name the method that is used to separate components of liquid air, state any uses of nitrogen and N1 use of oxygen, and then describe a positive test for oxygen gas. And then in the most recent Combined Science Paper 2, we are going to check what was the industrial process question. So the industrial process question, it was on number 11. It was on conduct process, which is the production of sulfuric acid. Candidates were required to name the raw materials that are used in the production of sulfur trioxide, give N2 conditions needed for the production of sulfur trioxide, describe how each condition stated in B affects the production of sulfur trioxide, describe the dilution stage in the conduct process, and also calculate the relative molecular mass of sulfuric acid. So in June 2024, I highly predict that on industrial process, there's going to be a question on Haber process. So make sure that you prepare for Haber process in June 2024. In your preparation for the Haber process, make sure that you understand the optimum condition and also the uses of ammonia. We are going to revise a question from November 2018, which was on the Haber process. So the question was on number 11. It is saying nitrogen and hydrogen gases are compressed in the reaction chamber at a temperature of 450 degrees Celsius to 500 degrees Celsius in order to produce ammonia. Describe what is going to happen to the yield of ammonia if the temperature of the reaction chamber was raised to 800 degrees Celsius. So what happens is the yield of ammonia is going to decrease since higher temperature causes the decomposition of ammonia. And then on part B, state 2 optimum conditions for the Haber process other than temperature. So temperature is 450 degrees Celsius to 500 degrees Celsius. And then we use ion catalyst, which is going to be in powdered form, and the pressure of 200 to 300 atmosphere is required. And then on part C, it is saying, explain why ammonia and other gases are recycled into the reaction chamber. The reason why we do the recycling is that it is going to retain unreacted nitrogen and hydrogen for further reaction. And then on part D, it is saying, state N2 industrial uses of ammonia. It is used in the purification of water, in the manufacture of fertilizers, manufacturing of household cleaners, and it is used as refrigerant. And then on part E, it is saying, calculate the number of moles in 56 decimeter of ammonia at room temperature and pressure. So you should note the formula of calculating the number of moles. The number of moles is equals to volume over molar gas volume. So the molar gas volume is 28. If we say 56 divided by 28, we are going to obtain 2 moles. I would want us to revise this question together. Number 7a, part 1, which is saying, name the elements which make up ammonia. So ammonia is a combination of nitrogen and hydrogen. By stating nitrogen and hydrogen, you get the 2 marks. And then on 7a, part 2, it is saying describe the Haber process. So when we are describing the Haber process, first we are going to state that hydrogen is mixed with nitrogen obtained from air. The gases are heated to 450 degrees Celsius. Steam is reacted with methane to make hydrogen. Liquid ammonia is pumped off to be sold, and then the gases are passed over an ion catalyst. Ammonia gas is produced, then cooled to a liquid. Unreacted nitrogen and hydrogen are recycled. Then the gases are compressed to 200 atmospheres. So make sure that in your description of the Haber process, you state that nitrogen is obtained from air, hydrogen is obtained from water. They are then reacted in the ratio 1:3. We use an ion catalyst under the conditions of 200 to 300 atmospheres and temperature of 450 to 500 degrees Celsius. So if you list all these 6 points, you're going to get all the marks. And then let us move on to part B. It is saying sebochemical Kanban was intentionally sited near Sebakwe River and Sesa Grid, which is nearby. Explain. So the reason why the sebochemical Kanban was intentionally sited near Sebakwe River, it is that we are going to have water that is going to be electrolyzed in order to get hydrogen. And then the Zesa grid is going to provide electricity for the process of electrolysis. This is to produce hydrogen that is used in the Haber process. In your preparation for section C, which is the chemistry section for June 2024, I highly recommend that you read about blast furnace. You can also see a question on blast furnace because it was last examined in November 2020. It has been a while. It has been a while blast furnace not examined, so there is a probability that it might be examined in your combined science paper 2 chemistry section. So we are going to look at the question that was on the blast furnace question that was in November 2020. It's reading, iron is extracted from iron 3 oxide in the blast furnace. name into raw materials that are fed into the furnace from the top. On B part 1, the raw materials that are fed into the blast furnace, we talk about carbon or coke, limestone or calcium carbonate, and iron ore. And then on part 2, it is saying write a chemical equation for the reaction that produces iron. So you should know that iron 3 oxide is reacted with carbon monoxide in order to have iron and carbon dioxide. So make sure that you're able to write a chemical equation using the chemical symbols. If they say word equation, you write in words, and then if they say chemical equation, you write using chemical symbols. So this is the chemical equation that we write for the production of iron. We are having iron 3 oxide plus 3 carbon monoxide in order to give us 2 ions and 3 carbon dioxide. So make sure that you are able to write this chemical equation. And then on C part 1, it is saying describe with the help of equation how sludge or calcium silicate is formed in the blast furnace. So make sure that you understand the equations for the production of calcium silicate. So in your description, you should state that the first step is that of the breakdown of calcium carbonate in order to have calcium oxide plus carbon dioxide. And then that calcium oxide that is going to be created is going to be reacted with silicon dioxide in order to form calcium silicate. So make sure that you understand these chemical symbols. It is very important. Then on C part 2, it is saying state in one metal which is added to iron to make stainless steel. So we use chromium and nickel. And then on blast furnace, make sure that you are able to label the blast furnace. At this point, we are having hot air or oxygen entering into the blast furnace, and also hot air or oxygen entering into the blast furnace. At the bottom, we are going to have molten iron, and then just above the molten iron, we are going to have molten sludge. And then at Ara, we are going to have the waste gases that are moving out of the blast furnace. And then we are going to feed coke, limestone, and iron ore inside the blast furnace from the top. So the question is now saying, name the substance that enters the furnace through S. So this is our S. So we are going to have hot air or oxygen. And then on part 2, it is saying, state what is released through Ara. We are going to have waste gases. So they can examine you to see if you can label the blast furnace diagram. And then you should be able to describe the main reactions which occurs in the blast furnace. What happens is coke or carbon is going to burn with oxygen in order to produce carbon dioxide. Then that carbon dioxide reacts with coke to give carbon monoxide. Carbon monoxide is going to act as a reducing agent and reacts with iron ore to give molten iron. Limestone decomposes to make the sludge which floats on the top of iron ore, and this can be removed. And then B part 2, it is saying, explain the advantages of having sludge covering the molten iron. The sludge protects iron from oxidation by atmosphere, and this keep iron ore clean. And then finally, it was a question on empirical formula calculation. It is saying a sample of iron oxide was found to contain 70% iron. Find the empirical formula of iron oxide produced. So make sure that you can calculate the number of moles. What you need to do is you list the elements that are present into that compound, right? In this case, we are having iron and oxygen, and we are given that there is 70% iron, which implies that the percentage of oxygen is going to be 30%. And then after that, we are going to divide by relative atomic masses of the given elements. The AR of iron is 56, AR of oxygen is 16. When we divide, on iron we are going to have 1.25, and then on oxygen we are going to have 1.875. We then divide by the smallest number of moles, so that on iron we are now having 1, and then on oxygen we are having 1.5. And when you find after dividing, you find 1.5, you don't round up, but you write it as a fraction, like what I did here, so that it is now 3/2. In order to remove that fraction, you then multiply both sides by 2, so that we are now going to have 2 ions and 3 oxygens. So make sure that you avoid rounding when you find after dividing the number being 1.5. So want to look at November 2023, the questions that were in section C. So the first question was on periodic table. The second question was on conduct process. And lastly, the third question, it was on oxidation and reduction. So in June 2024, in your section C, it's quite obvious that they are not going to examine on periodic table again. They are not going to examine on conduct process again, and oxidation and reduction. So make sure that you prepare for Haber process, you prepare for blast furnace, and also make sure that you can work out the questions on titration and organic chemistry. This marks the end of our tutorial today on final exam tips on chemistry section of June 2024, Combined Science Paper 2. Thank you so much, guys, for following me on this channel. Please don't forget to subscribe, like, and share my videos. I love you all. This is Eve signing out.